Hi, everyone. Thank you so much for coming back here at 6 p.m. So now we'll be going to start our panel discussion with all our invited speakers. And we know that it's been a long day, so we'll try to wrap it up within the next 15-20 minutes, including the closing remarks. That said, let me start by actually going around the table and letting each speaker just say a line about their current research interests and what they've been working on of late. Of course, we're all familiar with them already, but this would just kind of be an icebreaker.
Cool. Hello, I am Aleksander Madry. I am a faculty at MIT, and I work on many things, but I guess most relevant here is I work on robust machine learning and science of deep learning.
Hi, I'm Osbert Bastani. I'm a faculty at UPenn. I broadly work on trustworthy AI, and particularly I'm interested in safe reinforcement learning.
Hello, I'm Dan Moldovan. I'm a software engineer at Google in the TensorFlow team, and my main field of work is building tools that can help practitioners build machine learning models, both in research and production, and especially tools that make it much, much easier to do so than it's currently possible.
Hi, I'm Samir. I'm assistant professor at UC Irvine. I like to work in interpretability of machine learning, specifically debugging of NLP models, which are quite fun.
And I'm Cynthia Rudin, and I work on algorithms for machine learning. So the talk I just gave didn't have any of the algorithms that we designed, but we produce a lot of software.
Hi, I'm Deb. I'm a student at the University of Toronto, also a mentee at Google. And I'm interested in algorithmic auditing, so especially of like commercial API systems. And I'm starting to get into like benchmarking and documentation practice as well.
Okay, thanks, everyone. So let me start with a quick question again. We'll go around the table. So given that these days machine learning is being used a lot in settings like criminal justice and healthcare, which are of course high stakes domains, I wanted to get our panelists' thoughts on, as ML researchers and ML engineers, what would they advise us to focus on when debugging models which are intended to be used for high stakes decisions?
Okay, that's a very long question. Well, a question long to answer because there is many things. I think actually, amazingly, despite the fact that ML is currently used in many of the domains you mentioned, I think the biggest message is to even, make people realize they have to debug their models. I think this is not even a message that they really got, that somehow there is this belief of like maybe as a community we did too much of a good job about demos because they really believe this is magic that just works. So, this is something I definitely find. And then once you get through to them that, they need to debug their models, I think the important thing is for them to just sit down and think what they would really like their models to do. Like in a sense, what are the guarantees they would like their models to, to achieve? And then once they settle on that, how to test them, how to actually experimentally test that. So that's, I think, is still the battle that we have to fight. So.
Yeah, so I agree with all of that. One thing in particular, I think everyone really needs to keep in mind is that there's a large focus on this kind of idea in machine learning that you have a test set, and if you do well on the test set, then everything is good. But oftentimes the training set is constructed in a way that is not representative of the real world. So in healthcare, there are these issues where there are variables in these models that actually are indicators from the future that you wouldn't. So if you feed these to your predictive model, when you train it, you get 100% accuracy. But then when you test it, run it in production, you do terribly. So I think one thing we really have to keep in mind is that debugging models is not something that you just do once on your offline model and then you put it in production and you forget about it. We really have to, it's really a continuous process of monitoring how things are working, thinking about what the metrics we care about are, and making sure that we're actually measuring something that, when we're monitoring our system, that we're monitoring something meaningful, and then making sure that it's performing the way we expect.
Yes, definitely agree with all that. Probably one thing that I would add to this is that, well, in this discipline in general, in machine learning, there are many aspects in constructing learning systems that are not exactly mature. It's not just the model that's immature. There's the information theory around it. There's the mathematics around it. There's the tools and utilities that we have. Even the hardware is being currently developed. So there are many moving parts. Definitely be skeptical of everything. I think that's a good advice to always give. And definitely don't fall prey to the success of testing. Definitely in the real world, things will most likely behave differently.
Yeah, nothing to disagree with anyone. One thing I do want to say is that I don't quite see the differentiation between high stakes and low stakes machine learning. I feel like sometimes we think it's low stakes, but for example, Facebook news recommendation doesn't seem like it should change society, but in some ways it can influence us. So we should approach most machine learning applications as if they might be high stakes, and not think of a different toolkit because it's high stakes. But yeah, that's the primary thing.
So I'm going to build off of what Osbert was talking about. Confounding variables are really bad. There's been a bunch of studies from the Stanford Medical Group where they noticed that their X-ray predictions were depending on the type of X-ray equipment used rather than the medical content of the X-ray. It was like looking at the words in the X-rays. And it performed great in training. So we need to educate people on confounding because they just don't understand this. Right? They don't understand if you don't understand what your machine learning algorithm is depending on, it could be not depending on the thing you want it to.
Yeah, I agree with everyone. I think the one thing I would add is regards to sort of the evaluation step and how important that is in the debugging process. So even the sort of benchmarks that are sort of universally used within the community, especially like I'm thinking of computer vision in particular, where we take these test sets that are sort of given to us from these benchmark data sets, and we take that as a valid sort of symbol of progress. And I would sort of, I guess, challenge people to question that, especially when thinking about fairness and bias and representation of these benchmarks and these models that we sort of, these benchmarks and these data sets that we've sort of taken to mean something that they might not necessarily be representative of. And then the other sort of question or thing to think about with debugging is sort of who does this model work for? Like what's the best case scenario and who experiences that best case scenario, and what's the worst case scenario and who experiences that worst case scenario? So just contextualizing the use of the model and thinking about who's genuinely impacted once it's deployed is something that I think a lot of people should start considering when they think about what a bug means before they deploy a model in the real world.
Thanks, everyone. Along the same lines, another question that we wanted to get your opinions on was, as end users of these technologies, like for example, whether it's medical doctors or judges, what should they keep in mind at their end to sort of decide whether they want to use the models or not? I think Cynthia pointed in another workshop that either there is like this extreme paranoia about using a model in the first place where people are just like, nope, I know this is unfair, I know this is incorrect, I'm not using it, versus just adapting it blindly. Right. So how do the end users deal with these kinds of models now proliferating into their workspaces?
So that's a great question. And again, I definitely don't know the answer. I don't think we do know the answer. Because, for instance, one thing to keep in mind is that somehow we are thinking about interpretability, and that's great. But I don't think we keep enough in mind the fact that we are trained in machine learning. And many things that are immediately obvious to us would not be obvious to a very smart person who did not have this training. In particular, I very much agree with Cynthia's point that somehow like I think the whole notion of thinking of models as black boxes that give you the right answer is just fundamentally wrong. So the question should be how to kind of explain to people what the model is saying without just saying, oh, this is a black box that gives you an answer. I think it always should be something phrased in more nuanced statistical way, like language. But of course, the question is, how to distill down this kind of quite nuanced statistical statements to something that someone can actually understand easily without much of a training. And I don't know what is the answer yet, but this is something you should be thinking about. Like, we definitely should never tell people this is a black box that answers your questions, because people ask a question and they mean many things by it. And then they interpret the answers, even if they are correct, in quotes, in a very different ways. And we see there are a lot of very troubling, results of this kind of, interpretations.
Right. I think it's a very hard question to answer because it's very kind of dependent on the domain. I guess one bare bones test, like minimal test that you have to kind of think about is if there were to be some kind of the model that you train were to have some bad property, is that something you can even tolerate, right? And I think if the answer is no, then you probably shouldn't be using machine learning at all. If you can't, because there's always going to be some risk when you're using machine learning. I think that when you deploy your model in production, you discover, oh, it's done, something really wrong for the first, for the next day or so, and you won't. And if you can't tolerate that kind of risk, then I think you just shouldn't be using machine learning. But in the cases where at least some level of risk is appropriate, I think you should just be very careful. You understand what the risks are and make sure that you're you do everything you can to preempt them, and then again making sure that when you actually run it, you keep track of what's going on and make sure that nothing is going wrong.
So as a user, probably I would be an extremely picky user. Depends on the type of model, I guess, and depends on how much confidence would I have in that model. In general, I think it's healthy for a user to start with no trust on the model and let science, let verification, let tests, let perhaps some statistical methods prove the worth of that model, prove that that model can indeed produce useful predictions. If it's entirely a black box model, I would probably treat it as a crystal ball. Now, the model might still be useful, but I should be prepared for the fact that I might not understand ever why it makes a prediction or not. Just that most of the time it is correct. I should be prepared for it not to be correct. So I think that's how models should be taken. should be taken. And on top of that, as a user, I would actually ask for additional outputs from that model. I would ask that that model not just gives me a prediction, but it should give me additional outputs that helps me understand why it produced that output. I understand that's a tall order, but I don't think we should have a low bar there.
One thing I'll add again to what people are saying is the fact that I think the biggest problem when we look at a model and whether it's good enough or not is we look at a few predictions. Let's start with one. And if it is able to make the prediction correctly, we sort of attribute some level of intelligence to the machine. And somehow we feel like it matches our own in the sense that if it answers a difficult question, then clearly a similarly difficult question for us would also be something it would be able to do. And that's not how these models work. Their manifolds and their decision boundaries are not intuitive often and do not match our intuitions. And so whether it's just looking at one data point or even your whole validation data set, the predictions are not going to tell you how this model will generalize. So if you have specific ways that you think about generalizing, it's better to try and test your model on it rather than trying to do the inferences in your head and sort of hallucinating what the model would do.
I get to disagree with some of the panelists. That almost never happens in one of these things. Okay, so I disagree with the statement said earlier that you just don't need to use machine learning. You just don't use it. So I disagree with that because if you create a model that's just as interpretable as what a human would have come up with and obeys all the properties that a human would have created, like a domain expert would have created, then you can use it. And in fact, we have we've sent models into hospitals. We have all kinds of models out there that people can decide whether or not they want to trust it. And these models are of the same forms that humans would design themselves, they have designed themselves over the last 100 years. For example, sparse linear models. If you can actually design an interpretable model, you can actually judge it. And those models can replace humans, and humans are biased, and they're black boxes. So if you actually have one of these interpretable models, it actually can make decisions kind of uniformly more fair and can sort of, improve the quality of what we have now.
So I don't quite agree with that either. I think like what I was gonna, the initial comment I was gonna make, and then I can kind of, I guess, make a comment about what you mentioned. So the initial comment I was gonna make was for people that are thinking about adopting or integrating machine learning into their systems, it's really important to think about the safety risk to the end user, especially vulnerable populations, especially underrepresented groups. That's definitely not something that is always considered when people think about integrating a system. They're usually thinking about, the majority, they're thinking about percentages, and, if 80% of our users are satisfied, then that's good enough. But what if the 20% belongs to a vulnerable group that's traditionally marginalized? So I think these are considerations that aren't necessarily always top of mind when thinking about bringing a model in, and that's definitely a key consideration. I think another thing too, and this was mentioned by other panelists, was having the user sort of request particular information, much more information than they're requesting right now. So it's really funny how, if I was going to bring in software or, to my company, I was gonna, get a team to use a particular piece of software, I would look at the documentation, I would request particular information about the software's performance. I would make sure that it was secure, firewalled, safe. And for some reason, we don't have these expectations for some of the machine learning models that we bring into these very high risk scenarios. Even commercial APIs sometimes are really lacking in terms of documentation about the safety risk to the end user. So that's definitely something that I think should begin to be more common, especially with commercial API models and other types of sort of models integrated into systems today. And I actually sort of I agree with the earlier comment about maybe don't use a machine learning model for this. And I think the reason why that's a valid comment is because there are some very high risk scenarios where honestly, just given how little we monitor these models, the scale at which they operate, it doesn't, and the easiness, like the way we're so quick to trust these models versus sort of a human operator where we monitor them, we make sure that they are making decisions that are sound in some way. So I feel like because we trust these models so easily right now, and because they operate at such a scale and have such impact, like just by the characteristics of what these models are, they do inherently have these greater risks to hurt people. And in some cases, medical cases is one that comes to mind right away, but there's certainly others. Recidivism score, for example, it doesn't make sense to have a machine learning model at all.
So how can you stand the fact that judges are much worse than a lot of these very simple models?
Yeah, I get this question all the time, and I was like, is this allowed? I don't know. And I think, in my understanding, there's a certain amount of monitoring that we do to human decision makers that doesn't happen with machine learning models, where a judge's decision, there is some kind of external accountability that occurs. Same with decision makers, because a question was asked to me earlier about, if you have someone at a company that's making a decision about multiple people, how is that different from a machine learning model making that decision? So I think there's a lot of things. One is interpretability, which like you said, if we solve that, won't that solve the issue? But I think the other thing too is we trust these machine learning models to make decisions for way more people than we would trust many humans with. And then we also sort of don't look at them very frequently. So, even these commercial APIs that we audited before our study, it might have been multiple years before they updated the model. And then, suddenly we exposed their biases, and within 7 months, they've updated the model. So if they're not held accountable publicly, and embarrassingly, they actually aren't updated very frequently, and I think that's a huge risk, and that's the reason why, if it's a super high stakes scenario, don't take that risk. Yeah.
Okay. So thanks for the views, everyone. One question from the audience, if someone wants to ask the panelists a question.
Hi guys, all like awesome perspective on the topic of trust and interpretability. One question I have and kind of been thinking, pondering myself is, what we don't know, we don't know. So if we, as humans, we don't know, models are most likely not gonna know about it as well. Whether it's a person deploying a model for the first time, whether it's a model that has learned over a huge amount of data set. So what I've been pondering is like, what would be a good way to come around that? Is there something we can do about it? How do you guys feel about it? Any thoughts?
So yeah, so this is a question that, yeah, it's a bit philosophical, but actually it's very important to ask. Again, I think it all comes down to this kind of our unrealistic expectation of what machine learning models can do. Just the fact that it can outperform us in a very narrow task of like classifying some images into 10 classes or whatever doesn't really mean that they are smarter or better than us. And kind of there is on one hand there is like much of kind of disillusionment with ML is just because of that we have some like unrealistic expectations, and we are really disappointed if it turns out to be just something very, very dumb. And in some ways, again, so that's one thing to recognize. That's something that it's maybe not in our interest as a community short term, but it's very much in our interest as a community long term, is to kind of get this message across. And then, yes, it's very interesting. There are all this like trolley problem kind of phenomena in which we kind of ask, oh, what would this algorithm do there? Where to human, like we just say, whatever such situation happens in life, we say humans made the decision. We don't really judge was it a good decision or not. You said there was not much time, there was no good thing to do. Something happened, and we kind of are totally okay with that. If the machine does it, that's a very different statement. And I think the part of the point there is that that's a very good point, is saying that we just deploy ML at a different scale. And kind of, whatever tiny biases that might be there, they are kind of magnified to a greater extent by this. But still, like we should realize that kind of, we as humans are not perfect, and there is no reason to expect these things to be amazingly good. So we just should come to grasp with that.
Yeah, I mean, I agree. And I think it kind of comes back to my earlier point that when you have you always have to be prepared for there to be unknown unknowns and whatnot in your model. And I think even if you have an interpretable model that an expert validates, there could still be issues, unexpected issues that pop up in production. And that's why, going back to, like, we should have to be prepared to kind of continuously monitor these systems and be aware of these issues, that just because it got good tested accuracy, it doesn't mean it's going to run well. And just to kind of clarify my previous point, I think of healthcare and legal kind of decision-making contexts as places where these risks are to some level acceptable. We already run clinical trials and have patients take risky drugs. But there are some settings where really having machine learning model, at least the way we're doing now, is just really unacceptable to my mind. Things like in some certain robot control settings, like I'm not going to point out any specific names, but putting neural network controllers on self-driving cars and so on, where there is huge risk to humans, is, I think, one example where I think we have to be much more careful about the kinds of things we're doing.
Yes, and to build on that, I guess that explains why self-driving cars have been under development for 10 years now, and they still haven't released the market. Sometimes you have to be really, really, really cautious. I'm not sure I could give additional insight into this, other than my probably oversimplistic view that you judge a tree by its fruit. Not much more that you can do.
I don't have much to say about this.
Okay. Well, I mentioned confounding earlier at the same point.
Yeah, I don't think I have much to say. I think like the one thing I do think about is what I mentioned earlier, that like the goal in my mind, of machine learning systems is, I think it's the wrong thing to say that humans have this limitation, thus the system should also have this limitation. I think machine learning models aren't human minds. They are very good at certain things that we are not good at, and they are very poor. They're very bad at certain things that we are very good at. So for example, like humans, yes, we don't fully understand everything that factors into our decision making, but we have a certain amount of self-awareness and conscientiousness about when it's appropriate to act and when it's not appropriate to act. And that's not something a machine learning model has. So yeah, I think the bar in terms of interpretability and how well we should understand these systems is pretty high, because it is a machine, and just scientifically it makes a lot of sense to really understand how they come to their conclusions, and it's not necessarily justified in looking at the human brain and saying we don't fully understand how we come to our decisions. I think the bar is much higher for these machines versus a human brain.
Great. Thanks, everyone. So with that, we would like to thank our panelists. And just a couple of quick announcements. So we have the Best Demo Award, which, according to our judges, goes to Error Terrain Analysis for Machine Learning for Microsoft Research. Bessa, if you can please stand up. As we mentioned in the morning, all the Best Paper Award winners as well as the Best Demo Award will get gift cards from our sponsors, Google and OpenAI. And with that, I would also like to ask any of the program committee members to stand up if they're in the audience. Otherwise, just a note of thank you to them. And of course, if the co-organizers can please stand up, Sarah, Dee, and Julius. Thank you so much once again. And we would also like to thank our two co-organizers who could not make it to ICLR but played a pivotal role in organizing this workshop, Jacob Steinhardt from UC Berkeley and Rich Caruana from Microsoft Research. A round of applause for them. Thanks again for joining us today.